All right, so we're getting into a new unit, and we're going to be discussing some of the same functions we talked about in Unit 1. But in these particular functions, we're going to be worried about the graphs more and looking at their movement and being able to describe their movement. So today in class, we took notes about the parent functions, so that if I told you that g of x was equal to x squared, okay, you would know, oh, Mr. Schwann, I know that's a quadratic function, and I know it makes a parabola that looks something like this, right? Okay, we know that. Now, the whole reason that we did that today is to set up this. What if I wanted that same function, but I made a little change? Okay, so you still recognize, oh, that is a quadratic function. My big clue is the square at the top there. So if something is squared, like x is squared, that would mean it's a quadratic function. Okay, let me erase that real quick. So it's going to be x minus 1 squared. Okay, and so as some of you might recognize, well, wait, this looks a lot like vertex form that we learned about already. Okay, so if I had a plus 0 there, the only difference you would say, oh, well, this tells me the vertex is positive 1 comma 0. And a lot of students, again, confused, well, wait, why is it positive 1? It says minus 1 inside. Well, remember when we factor equations, for example, okay, if I wrote this, x minus 1, x plus 2, and if we actually solved for x, like these are the factors, but if we solved for x, we would set each parenthesis equal to 0, so x minus 1 equals 0, x plus 2 equals 0, and we would actually move 1 over, and x would equal 1, and in this case, x would equal negative 2. Right? So it's sort of the opposite. Whenever you have a number with x, if you just said, oh, well, if it's x minus 1, that means x equals positive 1. Okay? And so that's what we're doing. And if it's a number with x, remember the x-axis goes left to right. It represents that the graph is going to move either left or right when a number's with x. Okay? So in this particular case, we know the vertex is at 1 comma 0. Okay? So that means my new vertex would be right here. But nothing else changes about my graph, right? It's going to be the same width. It's still going to have the same kind of characteristics. All that happened is that I moved the graph over 1 unit to the right. So this is what we call a horizontal shift. So horizontal shift. Okay. And a horizontal shift, this shift went over 1 to the right. So I'm just going to 1 RT. So horizontal shift 1 unit to the right because of this x minus 1 there, which really means we do the opposite. So minus 1, we usually think, oh, I go to the left 1, but we do the opposite, so we actually move to the right 1. Okay? So half the battle is recognizing what kind of parent function or original function do I have, then being able to recognize, okay, I know what that's supposed to look like, then how do I move that function based on what values are with x or what values attached to the x. So let's go ahead and go to our next slide here. Okay. Oh, and is it really doing this? All right, little issue got to fix. So now looking at this graph, again, x minus 2 squared. Okay, first thing I need to recognize, oh, this is a quadratic function. Again, if I were to graph this on this graph, it would look something like this, right? Something like that. But the minus 2 right here with x tells me, okay, the graph's going to move. And it's going to move along the x-axis, but x equals positive 2, so that means I'm going to move to the right. So I'm going to write RT 2 units. So that means I go 1, 2, and the only thing that changes is where the vertex is. Everything else is the exact same. All right? All right, so our next slide here. So I'm looking at x plus 3 cubed. Okay? So I notice that I have a cube now up here, and that means I have a cubic function, which means the origin is here, and the graph will kind of snake up this way here and kind of drop down this way here. Something like that, right? And then the plus 3 with x tells me, okay, so that means x equals negative 3, which means that's going to be a left 3 shift. So my graph is going to move over 1, 2, 3 units this way, but everything else about the graph is the exact same. The only thing that's different is where the graph starts. So everything else is the same. It's still a cubic function. It's just I moved it over 3. All right, so you notice the change on this graph. Again, hopefully you see, oh, well, Mr. Schwandt, this is an absolute value graph. So I know it's a V that looks like this, something like this. Okay. Now, in this graph, you'll notice that the change is not with x this time. It's on the outside. So notice how this plus 1 is on the outside of the x, it's not inside the absolute value bars. Okay? Whenever you see a number on the outside of the parentheses or the absolute value bars, that means it's a vertical shift, meaning I either go up or down. And remember, for vertex form, whatever number is on the outside, we just do what it says. So this one's a plus 1, so the only difference between the green graph and this function with the plus 1, I just move my whole graph up 1. It's the exact same graph, but the only thing I did was move it up 1 unit. Again, hopefully you're looking at this and saying, Mr. Schwandt, obviously this is an exponential function, okay, that looks something like this. Again, it's going to taper up, then take off real fast there, okay. That's what normally this would look like, okay. But I notice that there's a minus 3 here, and it's not with the x. It's kind of the back end of the problem. So that means we would actually move my graph down 3 units. So 1, 2, 3. So now my graph would look something like this. Where normally for an exponential function I have an asymptote at 0. But because I moved down 3, my new asymptote would be at negative 3. Okay, so that kind of gives you an idea of what we're discussing. There's a couple of quiz questions. Hopefully you're able to see this and say, okay, I kind of figured this out, but we'll talk about it more in class.